The measurement system. Our customary system of measurement, which is given in the figure, is part of our cultural heritage from the days when the 13 colonies were under British rule. It started as a hodgepodge of Anglo-Saxon, Roman, and Norman French weights and measures. Since medieval times, commissions appointed by various English monarchs had reduced to chains of measurement by setting specific standards for some of the most important units. Early records, for instance, indicate that an inch was defined as the length of 3 barley corns, round and dry, when laid together. A pennyweight, or 1/28th of a tower ounce, was equal to 32 wheat corns from the midst of the year. The US gallon is the British wine gallon, standardized as the beginning of the 18th century and about 20% similar than the imperial gallon that the British adopted in 1824 and have since used to measure most liquids. In short, as some of the founders of this country realized, the customary system was a makeshift based largely as folkways. Now, metric system. The metric system is the dominant big language of measurement in use today. Most of the world countries used the metric system prior to World War II. Since the war, more countries have converted or are in the process of converting to the metric system. Only the United States and 13 smaller countries have not made the conversion. Congress has the power to define the standard of weights and measure. Repeatedly, the metric system has been proposed, and each time the question have been voted down. The metric system was developed by a French statesman, Talleyrand, Bishop of Autun, using a meter as a standard. The meter being a specific portion of the circumference of the earth at the equator. From this base measurement, the meter was developed and accepted as the standard. Division and multiples of the meter are based on the decimal system. Now, the logic of metric. No other system of measurement that has been actually used can match the inherent simplicity of international metric. It was designed deliberately to fill all the needs of scientists and engineers. Layman needs only know and use a few simple parts of it. It is logically streamlined, whereas other stream systems developed more or less haphazardly. At this time, there are only 6 base units in the international metric system. The unit of length is the meter. The unit of mass is the kilogram. The unit of time is the second. The unit of an electric current is the ampere. The unit of temperature is the Kelvin, which is common use is translated into the degree Celsius, formerly called degree centigrade. The unit of luminous intensity is the candela. All the other units of measurement is the international metric system are derived from these 6 base units. Area is measured in square meters, speed is meters per second, density is kilograms per cubic meter. The Newton, the unit of force, is a simple relationship involving meters, kilograms and seconds. And the Pascal unit of pressure is defined as 1 of the Newton per square meter. In some other cases, the relationship between the derived and base units must be expressed by rather more complicated formulas, which is inevitable in any complicated formula. in any measurement system, owing to the innate complexity of some of the things we measure. Similar relationship among mass, area, time, and other quantities in the customary system usually require similar formulas, made all the more complicated because they can contain arbitrary constant. For example, 1 horsepower is defined as 550 foot-pounds per second. Now, the third intrinsic advantage is that the metric is based on the decimal system. Multiples or submultiples of any given units are always related by powers of 10. For instance, there are 10 millimeters in 1 centimeter, 100 centimeter in 1 meter, and 1000 meters in 1 kilometer. This greatly simplifies converting larger to smaller measurements. For example, in order to calculate the number of meters in 3.794 kilometers, multiply by 1000. Move the decimal point 3 places in to the right, and the answer is 3794. For comparison, in order to find the number of inches is in 3.794 rules 794 miles, it is necessary to multiply first by 5280 and then by 12. Moreover, multiplies and submultiplies of all the international metric with units follow a consistent naming scheme which consists of attaching a prefix to the unit. It may be, for example, kilo stands for 1000, 1 kilometer equal to 1000 meters, and 1 kilogram equals to 1000 grams. Micro is the prefix of 1 millionth, 1 meter equals 1 million micrometers, and 1 gram equals 1 million 1 million micrograms. Conversion, metric to conventional. People tend to resist changes usually because they do not understand either the purpose of the change or the new order. Terminology for customary units and metric units have been discussed. A conversion table also has been included. Example of its use follow. To convert into millimeters, multiply the number of inches by 25. Example, 25 into millimeter equals to 25 into 25 equals to 625 millimeter. To convert millimeters to inch, multiply millimeters by 0.04. Example, 625 millimeter into 0.04 equals to 25 inches. To convert square inch to square centimeters, multiply by 6.5. Examples, 100 square inches into 6.5 equals to 650 square centimeter. To convert square centimeters to square inches, multiply by 0.16. Example, 100 into 0.16 equals to 16 square inches. It is practically well explanatory. Measurements started by 1 by 64 of an inch up to 20 inches have been converted to decimal division of inches and to millimeters. Now, mathematical hardware. While there is no substitute for a basic understanding of mathematical principles and a certain degree of proficiency in performing mathematical operations, we can benefit in both speed and accuracy from the use of certain mathematical hardware. This hardware may be detailed function tables or the electronic calculator. Either one is easily obtainable, portable and easy to use. The decimal equivalent chart and the function of numbers chart are the presented here for your convenience, for the convenience of making common calculations. As you become familiar with the information presented on these charts, you will begin to see the advantage of ready-made computations. Now, number 2, electronic calculators. The advent of the inexpensive handheld electronic calculator had changed forever the way that we perform mathematical operations. While the technician still needs a basic understanding of mathematical operation and logic, the calculator can help increase speed and reduces errors. There is no right calculator for the aviation maintenance technician. As we have previously mentioned, there are calculators with function keys for many of the operations that we have discussed: square root, metric conversions, and the 4 basic mathematical operations. The selection of a calculator should be based on the anticipated use. All calculators do not work alike. You may borrow a calculator only to find that no matter what you do, the answer do not come out correctly. This may be because there are 2 basic calculator formats. The conventional format is necessarily used on an expensive household like calculators. It uses a straightforward method of entering numbers that is identical to the way you would do arithmetic on paper. If you want to multiply 7 into 4, you press the key on the following order: 7 into 4 equals to what you will get. As soon as you press the equal sign, the answer will appear. Complex engineering type calculators may use a different format. This is known as the reverse Polish notations, or RPN. To someone who is used to the conventional format, it will seem clumsy and somewhat confusing. After getting accustomed to it, however, it will be uneasy as the conventional format and may prove more versatile for complex calculations. Whatever type of calculator used, they are an invaluable aid in complex operation or in manipulating large numbers. One thing I have left in the chapter of sound, which is called Doppler Effect. Today we often encounter the term Doppler Effect in the discussion of electronic navigation and control system, as well as in the discussion of sound. This is possible because both electromagnetic energy and sound travel in waves. The Doppler effect is observed in sound when the source of sound wave changes in direction with respect to the hearer of the sound, that the number of sound waves per second reaching the ear is changed. Let us assume that a whistle is emitting a sound with a frequency of 1100 Hz, and that the whistle is mounted on the automobile approaching the listener at a speed of 100 feet per second. Assume also that the temperature is such that the speed of sound is 1100 feet per second. Then with the frequency of 1100 Hz and the speed of sound 1100 feet per second, we know that there will be one sound wave, that is in bracket cycle, for each foot distance from the sound source. Since the sound source is approaching the listener as at 100 feet per second, the listener will hear 1100 plus 100 or 1200 Hz. That is, the sound will have a higher pitch than that at which it is emitted. When the sound source reaches and then goes away from the listener, the pitch will suddenly change, so that the listener will have a pitch of 1000 Hz. The apparent change in pitch is called the Doppler effect. The formula for determining the change in frequency as a result of the Doppler effect is uh, rho equals to, sorry, small p equals to small f v, capital V divided by capital V minus S, source moving toward listener. And now P equals to small f V, capital V divided by capital V plus S, source moving away from the listener. These two formulas are there, where P equals to apparent frequency of sound heard by listener. Now small f equals to frequency of sound at source, and capital V equals to speed of sound, and capital S equals to speed of source. The Doppler effect principle is used in electronic indicating system because electronic signals are transmitted by means of waves, and the apparent frequency of a signal from the approaching signal source will be higher than the frequency of a signal from a signal source, that is moving away from the receiver. One of the principal applications of the Doppler effect is in electronics in navigation radar equipment.